So in this video, I'm just going to be showing you guys how I go about setting up my hydraulic mimic circuits. And the reason I'm doing this is I want to try and document all the processes that I'm creating. So I'm doing really well over the last few years, and I'm just kind of like doing a lot of work and moving on. And I'm looking back and going, damn, I've done quite a bit actually. So what I wanted to do is a lot of my colleagues, or in particular, two of my colleagues have developed, or my company, I guess, as a whole, previously, we do hydraulic systems. And so for the hydraulic system, you have a hydraulic circuit that looks like this, yeah. So this is a relatively small circuit, big, small kind of, yeah. So you've got four main motors and main pumps here, and then you've got a further two pumps and two main motors. Sorry, a further four motors, four pumps. So this is not a large circuit, but it's also not a small one. So you could get a circuit with 10 times the size of this, with 10 times as many components. So if you see all these red things, these are all switches. Got a bunch of filters there, switches. You got heaters there, loads of components. So generally, what we want on our HMIs is to be able to display the status of all of these devices. So what ends up happening is there's a decent debate as to how extensive a mimic screen should be. Should it show every little thing on the hydraulic circuit, or should it be more of a block diagram? And where are all those gray areas in between? So if you don't know hydraulics, it doesn't really matter. But if you have a check valve there or a test point there, do you want to display that or not? And so I'll show you some of the examples of some of the other hydraulic mimic screens. But what I've settled on and what I've found is that if the mimic screen doesn't show absolutely everything, then it ends up just being not good enough, and then they just always go and get the hydraulic circuit out on a big bit of paper. And so I've kind of decided that I'll go with the whole exact hydraulic circuit. So what I do, essentially, my process is I take, and this is what you're looking at is WinCC Unified, but what I'm saying is not specific to WinCC Unified at all. You could use it on any HMI software. So essentially what I do is I get a PDF version of the hydraulic circuit. I then convert that to an image, a PNG image. I invert it. So usually the PDF is white with black lines, sometimes different colors as well. So I invert it so that I've got white lines on a black background. Then I remove the background, and then I import that image as a PNG with a transplant background onto my HMI, so that way the hydraulic circuit, the background, has this exact same background as the rest of my HMI. So as I flick through my HMI, you can see that the hydraulic mimic circuit fits just exactly the same with the exact same background. And then what I've done here is, this is a screen window, which I guess it will be the same on whatever HMI software you're using. So I've just got a screen window here that sits here, and then this image is a big, massive, 6,000 by 6,000 pixel screen, whilst my normal screen is 700 by 1400, for example. And then this allows me to pan around inside the screen window without panning around, without moving the whole, without moving the whole HMI. So keeping the rest of the navigation the same, etc. Essentially. So I will show you some other examples to show you what I mean. But so for example, I'll give you actually another example of what happens when you well, okay, I guess in terms of time wise, this takes me to get the PDF, invert the image, and then remove the background. That takes me 10 minutes. So I'll do it in 10 minutes. For somebody else to draw this out using components line by line, creating these valve faceplates or whatever, what kind of valve is that? You know what I mean? So for someone to do that and write all these switches, it takes, it could take 2 months, 3 months. And then there's so many mistakes as well. You miss out this test point here. It's just, yeah, to me, this is my favorite way at the moment of doing a hydraulic circuit. So let's go through it. I'll step through it with you. Let me find the PDF circuit. All right, so here's the PDF drawings for this hydraulic circuit. So you can see it's just a very bog standard PDF. And then what I'm going to do is, and a bit tricky really. Sometimes it comes as a PDF, sometimes it comes as a DWG file. So maybe I should show you it from a DWG file. All right, here we go. I've got the DWG file. If it comes like this, then yeah. So this is typically, this is hard to look at. So this is typically what the circuit looks like. So I've got a hydraulic circuit here with, you know, a bunch of different layers and really hard to look at colors. So from here, I need to get this into a PDF most of the time. And that is probably the hardest part. So if I do file, save as, I don't think, so if I do PNG, so I can save it directly as a PNG file. Don't think that is going to look good. So let's try it. All right, so here's what that looks like. So as you can see, I've saved it as a PNG file and it's completely, utterly illegible. What I'll do then is I'll go and I'll find a DWG to PDF converter. I'll keep spamming these websites until I get a format that looks right. So as an example, this one I was using seems to have just frozen at 70%. It's been there for 2 minutes now. This website's still stuck at 70%, so that ain't gonna do it. Okay, that's, I don't know what this has done. I've seen this before. It's produced 3 different versions. This actually looks good. Yeah, look, that's really nice and visible. So what website was this? This was cloudconvert.com/DWG to PDF. And that has produced, that's readable. If you look at that, you can read all of that. So we got this super bright, ugly looking PDF. And so what I want to do is I obviously need to get it to look like this. So the way that I'm going to do that, I mean, you could use any imaging software. I have a Irfan View. This is actually, I think, free and open source, which is incredible. So I'll open the PDF in this. So it looks like this. Then what I'll do is I'll do image and I'll negate or negative invert the image. Boom. So that gives me that. Then I'll do image, convert to grayscale. Now I've gotten rid of all them ugly colors. Then I'm gonna do, and here's this is where again you could do this on anything. I'm gonna select a gray color and I'm saying replace color and replace all gray with white. And then I'll just set a tolerance of like 10 for now. That didn't do much. Then I'll do image and I'll just increase the tolerance of that. So replace color, let's do 40. I got a bit more white there. Issue. Can't see. So look at that valve there. So image, place color, let's do 70. That's getting a bit white. Image, place color. Eventually I'll go up to so 100, I'll go to 120. A bit more white there. Image. I can't see everything. So let's go for a slightly darker gray. Okay. Place color. Boom. I've still got a bit more gray there that I want to keep. Oh, I got it. Look at that. I got it. Boom. Nice. It's a bit thick. It's going a bit thicker than I want. So 60. Maybe there's nothing I can do about it. Yeah, anyways, I'll take that. So now I've got a lovely black and white circuit. Ah, that looks beautiful. So now there's an issue with exporting these. I think plugins, PDF options. Set your DPI for that high if you're using this Infran. Obviously, like I said, you could use any imaging software for this. And this one's just free and open source, and I would like to support as much free and open source stuff as I can. Our file, save as, save this as a PNG. Save. I could make it transparent actually. Let's save that, and then let's try save it as transparent. Save as Save transparent color, save transparent alpha channel. Don't really understand what that means. Go for it. Compression level 0. Do not compress. See how that looks. So, I mean, that's brilliant. Look at that. That is brilliant. That looks transparent. Ah, has it done it? Oh, it's a bit thin. It's all a bit thin, but to be honest, you take that. All right, yeah. So we have a transparent one there. So I'll use that for now. Now what I can do is I can go back into this project. So yeah, I'll show you on here. So what I do then on my Mimic screen. So this is, if you use Siemens, you know what this is tier portal. If you don't use Siemens, it doesn't matter. At this point, you get the drift. I've got a hydraulic circuit. I've inverted it. I've made it transparent. And then now, what I'm doing is I have the screen I'm going to display for the user, which is a screen window. If you see here, that's this screen window here. And then inside there, I've then got a much larger screen, which is the hydraulic circuit. And essentially what I do, if I get rid of the grid. So yeah, all I've got now is I've just got literally that hydraulic circuit with all of these just circles and squares overlaying on top of it. That then show you where, if the thing's on or off. So here, for example, I've just got a very basic visualization. It's a green circle. And on top of that, I've got a tag. I'm looking at that tag. If that motor is running, then show the circle is green. If that motor is not running, then show the circle is grey. So what I will do then at this point is I will go get my circuit. I drag it on here. This is usually where tier portal will decide to crash. There you go. So I've got my transparent circuit. Right, so now I have my circuit. This circuit is actually higher quality, much higher quality than the one that I've actually done. Much larger. Oh, that looks so good, man. I'm not gonna line everything up, but I'll just, can I line it up? Probably not. E1 motor. Yeah, it'll be about there. I guess I can make the circuit smaller. I mean, bloody hell, look at how high quality this is. Crazy. Anyway, so alright, I'm not gonna line it up, but you get the gist. So if I simulate this now, I think this is gonna look even better than this one. So mine there, you can see it's still a little bit blurry, but it's kind of was good enough for me at the time. But simulate this now. And honestly, the thing you got to think about is how long would it take for an engineer to sit at his desk and draw this circuit out? I mean, there's probably 60, 70 switches on there, 40, 50 valves. So that whole process took me, like probably 10 minutes in terms of getting the image to be right. But, I bet you could probably write some sort of script and some image editing tool somewhere to do that for you in one click. I think I've sat here for 5 minutes. Just recompiling and whatnot. Alright, anyway, so hydraulics and boom. That is clean. That is beautiful, readable, eligible circuit. I like that a lot. And so obviously all I'd need to do is I just would take that square that's rotated as a diamond, put that on top of that, take that square, put it on top of that switch. So the longest part for me about making a hydraulic mimic screen is just getting all these tags right and just dropping all the relevant red and green circles and squares. And then obviously all the IO fields for things like pressures, voltage, feedback, that stuff. But yeah, I mean that to me is, so I'll actually I'll simulate some of the other mimic screens that we make. How it obviously looks. So when it's done, I've just got, if the valve's on, it will be green, and if it's off, it will be red. Yeah, that's how the circuit looks normally. Now I'll show you my colleagues' mimic screens, two of them, and I can tell you now, where you could make this mimic screen in a week, their ones, you're talking about. So this is maybe half an hour to get the hydraulic circuit on the HMI, and then I mean, really, in reality, you could stop there and just have it so that at least the person has the circuit on the screens. But then, if you want to make a mimic screen, you can drop all the animated red and green circles and whatnot, squares. So that's half an hour's work, an hour's work to get the circuit on the screen, and then a week of tagging it up, depending on how much IO you got. 2-3 days to a week to 2 week stops. But the other guys' ones, you're talking about 2 months, 3 months of just creating mimic screens. So I'll show you them. I'll simulate those projects now. All right, so here's an example of the same circuit, but drawn out by one of my colleagues for his screen. And you can see he's taken the time to draw. I don't think like he does, yeah. So every single component here, and if you look, like, it's a lot sharper than what displayed on mine. So zoom into the same area. Let's go. This is. So he's taken the time here to draw that whole valve out. So that valve. You can see he's drawn the check valve there. Now, the problem that you get with this is that, does this have all the information you'd want? Probably. Yeah. Can't see anything obvious missing there. So you got filter. So literally, as you can see there, he's literally drawn out everything. So where he's filled in a circle that I could put a circle on that. So it depends, I guess, on what approach you want to take to this, but his one here has probably thousands of components in terms of lines and squares. But now what we found is, on site, when we've been looking at stuff, you'll be looking and it's not quite right. There's like small details missing. So if I go, what valve is this? V101. Myself up. Okay, V101. That's just a test point, so he hasn't drawn that. That's okay. 1, 2, 3. V straight through the drain. Yeah, it's tricky. I mean, that's the thing. When I'm looking at this mimic, I don't know. I would probably leave off the same things he's left off. Yeah, it's hard to say what I prefer, to be honest with you. If I had unlimited time, I'd probably prefer to draw it out. But then it's just me knowing the amount of effort it takes to do this one on the right versus doing that. I must say, I do like the lines being clean is very nice. Although then obviously you just got the painstaking pain of having to line up all these sorts of lines. But yeah. Anyways, yeah, so that's how I go about making my mimic screens. And for me, it's a lot faster to do it like this. And then I know for sure as well, there's no accuracy issues here. I have every single valve, every single test point, every single relief valve, everything there. I do think there would be a lot of merit, actually, and probably what I'll prefer to do is to have this entire circuit and all the IO on it, so just as I do, and then do what he's done here with this circuit, but have it as more of a block diagram. So without actually drawing out all the valves, just having a square that says V10, V9, what is that? YV108, V128, and then having just a blocked up mimic diagram of that. So a lot more simpler than this, basically. Then that way, I think that would be a happy medium of having a pretty looking mimic screen, but then also having a mimic screen with everything on it. So, anyways, yeah, I'll wrap this video up here. Hopefully you enjoyed it. It's pretty basic, really. Take the hydraulic circuit, invert it, remove the background, and chuck it on your HMI. and then just drop all the IO on. Cool. All right. Hope you enjoyed it, and yeah, I shall see you guys in the next one. Take care.